Here, I will just clean this Kafka message, okay? So I have here directly. Okay, let's recreate me. That would be more easy because I have to do through command line. By making retention period, I can make a very minimum, then it can delete all the messages quickly. Paste Kafka topic 2. I will simply delete and recreate it. Paste Kafka topic 2. Let me do a partition and add. Seems it hangs. Trying to delete and create. This is not doing anything. Let me check if services are running. So this is timeout. Let me quickly cancel and restart this Kafka. These services are good with the distributed machine only, where we have multiple machines as a server. Single machine means everything is running at a single machine only. If my laptop gone off, then everything is off. Again, need to restart and all. Okay, this is also this is done, and this is also done. Fine. Now I will timeout connection. This is not running, that's why. So let me restart it again. This is zookeeper properties. It is saying input line is too long. Syntax or command is wrong. No, this is fine only. Okay. Let me see the command from here. Starting zookeeper. This is starting zookeeper. This is same, right? And I believe that I am in the Kafka bin window zookeeper server.bat. Yeah, this is fine only. What is the issue? CD. What is this? Okay. Just give me 1 minute. We were here inside Kafka, and inside Kafka, we had this was Kafka, right? Here we had the installation and we have to open one CMD here and not here. Again, I'm wrong. Let me. Why this is taking too long? The same syntax. Let me run from here itself. Let me do one thing. Let me completely refresh it. I will close all the things and I will do it again. It will take less time rather than doing lots of things here and there. Let me delete this as well. Cancel this and then cancel this. And let me delete this as well. Now I will go to training. We had already explored it 2.3.2.1. Then let me extract. And let me take this. And we are here inside Kafka. Let me paste it. And then in Notepad, we added this. Let me save it. This was the zookeeper property. Let's save it. This was server properties. Let's save it. Okay. And then let's start the service. Yeah, this is done. Now let's go to folder and start it. So we have to open one CMD here. And then we can start with the commands. So this is the command and let me run it. Yeah, that's better. Then I will start this one. This is the server. And I will open one more CMD here. And let's run it. So server also started. And then we need to see if topics are there. So let me refresh this correction. Okay, topic created successfully. And if I refresh this, as of now, I have single topic. Okay, because I completely deleted all the things from the previous one. So now it is refreshed. Only this topic is available now with no data, zero data is there. Okay, now quickly we can start. So here I have written few programs. Okay. First of all, you have to understand about the streaming that you can have multiple sources, right? You can have either maybe let's say some streaming is happening through some web API, means some web application, webs or some files, some data, some device, some device data. Multiple things can be there. You are getting through a variety of sources, and you are trying to process that. So let's say, for example, I am having this folder itself. This is the folder. You can assume that at any folder, files are keep on loading. means data is generating somewhere, then that data is getting converted to file and saved to this location, and there can be multiple file. Today it is means as of now it is having a file underscore one.csv. It can have something. After a few minutes or few seconds, there can be file 2.csv. So time to time files can be appended. In that case, you can directly write the streams like you can forget this, you can avoid this. This is just a setup for my machine. Like you are having the Spark session, then this is the schema, custom schema if you want. Otherwise, you already know about this header and info schema, right? You can go with that. Then read stream format CSV. Like you yesterday we seen format equal to Kafka. That means you are reading and writing to Kafka. Then you are giving format Kafka. If you are having other sources, then you can change the format. You can go with some file formats or maybe some source or target, whatever it is. So here I am assuming that it's a CSV. Then okay, then let's say take format CSV. Then it will be enabling the system to run read that and even write that. Then whatever option you want to give, like header, true, schema. Then this is your file input location, and then it will be keep on writing wherever you want to. Let's say here this is just a format console, this is console print. If you want to in the real time, we are not going to do with the console. You are going to write again that output to some, maybe as a file, or maybe you are pushing somewhere in the table or in the Kafka topic, or maybe something else. That there can be different use cases. So in that case, you can again write in that format whatever you want to. Either you want to write in the CSV format only, or Kafka, or console, whatever you want, you can do that. So if you look at here, there is nothing, only what you are doing. You are taking this Spark session. After the Spark session is done, then schema, that is for your data. Then read stream. Instead of read, you are giving read stream. Then you are giving write stream, and then await termination. That means until unless you kill the job, uh, or you stop the job forcefully on your own, job will keep on running and it will be taking care. It will be just looking out. Okay, if any data is coming from the source, this will process that. So that will be for the streaming, but this is rough coding, right? If you are practicing, don't write like that. You make a proper class, then proper functions, parameterized functions, pass the input parameters, and then process that. Same if you if you are looking for the batch, then this will be simply read and write. Simply you can remove the stream. That's it. There is no much difference. Then this is for the batch, Kafka batch reader. So here what I'm doing, simply this is my Spark session, and here this is the Spark SQL Kafka. I have made it to available. What you can do, if I am not downloading this, the better thing is download it at your system and then set up the path in the config. Then always it will be taking that from that path itself instead of making it download and available. Otherwise, what will happen if that is not set up from my system? It will be always looking for that package and it will try to download. In my case, I have not downloaded it. Okay, so if this is not available, this application will make that available. So for the better thing, you can make it available in advance and then that can be reusable, because always and always if it is downloading or making that setup, of course this will be taking some more time. If milliseconds also, this is going to take some time, so we can save that time, we can make our job optimized. Okay, then this is my Spark session. And then here, if you see there, I show you a format was CSV, because that was CSV. Here I want to do stream with Kafka. So I am taking Kafka. That means stream is not with Kafka only. That's what I wanted to show you. Stream can be without Kafka also. You can have different variety of sources, variety of targets. Only the thing is Kafka is having its own functionality, that it is providing you retention period, it is providing you replica, high availability, scalability, and it is maintaining the offsets. So if you are reading the data, it is saving the offset that next time you are going to read this one. So it is having lots of management internally. That's why that is preferable, because this is taking care for your data and all. If you look about the CSV streaming, this is not taking care about this. Okay. Let's say this is happening with the file 1.csv, 2.csv, but retention periods and all you are going to manage whatever you want to manage for the, either for the high availability or its retention and all. You this is now in your hand how you want to. But in Kafka is taking care of many more things. That's why Kafka is preferable for streaming kind of services. So here I'm taking format is Kafka, then again bootstrap server. This is the server. Make sure that server is running. Like just we see it was not running, so it was not creating topic also. Because if that is not available, service is not available, how it will? So once that is available, it is running, then it is good. Then subscribe. Subscribe means which topic you want to subscribe. So I am giving same name. Just now we provided or as a new topic name. Then option starting offset. I want to read from the earliest. Okay, and then load. And next select expression. Just I am casting that. So here I can comment this out and let me run this. Okay. Uh, why this much data? I did print. Okay, I did so 2 times. df dot so. Okay, now can you tell me why data is like this? This key and value. Here you can see key and value, and here you can see key, value, and topics and partition and offset and timestamp type, because here I have given uh, I believe that it is running the same data. Kafka batch reader. Let me run this again because it is printing something else. Okay, now only single print. Now you tell me, you understand about this key and value and this one, right? What is there? Key and value. Then topic. Then this is the offset. This is the partition. This is the timestamp value. Why this data is like this in this format? Any idea? This is not readable, right? So why is this?
It's in bits, I think. Need to
Hmm?
convert to string.
Right. So by default, this is in the byte array, right? So because of byte array, this is coming like this. And I believe that some program is keep on running. Yes, this one. That's why, because I was thinking that right now I have created the topic. How come this is getting the data? So let me recreate it one more time. I will just delete it and I will recreate. Test Kafka topic 2. Because we had just created, right? It should have blank. But another program was keep on running for pushing the data. Test Kafka topic 2. Test Kafka topic 2. Let me take fourth partition and create it. I hope all good and it did not.
Topic
Okay.
name already exists.
I think this is. it should not impact, but not sure. As I deleted it, this is also got timeout issue. Let me restart it. This timeout issue for the zookeeper. Yes. Then let's run this, and for the server, this is also having. So let's run this again. If you see, if zookeeper is I am terminating, then server will also terminate. So both should be running parallelly. Now this is fine, and my topic is done. It's marked for deletion, and here let me refresh it. Refresh. I think I should restart my laptop. That's the most required things. Even I restart, but not every day. I have not restarted since last 2-3 days. Okay, services are keep on running. It should be fine, but again, I guess some issue is happening again. Reconnect request is coming from here. Let me take care of this first, otherwise it will keep on disturbing. And let me do this. Refresh, I will close it. Task manager. And then this is Offset Explorer. Let me cancel this. This is done. Now I will start it. Zookeeper. And then I will start server as well. Then I will start Offset Explorer. Agree. Then let's make it connection. I think it is getting continuously so, right? As if I run this code again, let me see. Because that is getting timeout connection issue. Yeah, connection issue is there. Could not be established. This is doing wrong thing today. We do not want to debug it again. I think I'm not sure what was the issue, but I just deleted the Kafka topic. I believe that that is not the reason, but can't make sure. Kafka zookeeper, then zookeeper data and leaves. Then I will simply close it and I will repeat that one more time. That's not a good practice. We can make it stable. Then I will take from here. I believe data is there. Yes, it is. And we'll go to back. We'll copy this.
Still on the background,
No, I have cancelled all the
some
thing. This
message saying no, something is using this.
site doc is unavailable. If the location on this PC, make sure this is connected. I'm not looking for this. This is asking for some location. I don't know what is this. This is just wasting my time, nothing else. Okay, so I will just go through this and I will do resave again for this zookeeper and properties. Just saving it and then I can start it. Kafka CMD. And now I will not delete the topic. I guess that is impacting. Then I had this command. This is for server. First I need to do for zookeeper. So let's copy and paste here. This is done. Now let's come to server. And I need to have one more CMD. CMD. And let's run this as well. Now I will check if zookeeper is running fine. Okay, now it is okay. Then I need to come here. I will refresh this connection, reconnect, and it is done. Topic, there is no topic as of now. So let's have the topic. Test Kafka topic. We had named it 2, right? So make it and then 4. It is done. As of now, it is having no data. It should, but let's check it. Data, there is no data. And properties, as of now, this is byte array. So let's make it string. As of now, we have no data, but just I'm updating it. And count is 0. Here you can see. Now it's okay. So if we try to read this data now, let's run this file again. So as of now, there is a 0 record. But if you see, did I set up anything for selecting the column name? No, I have not. But this is taking key, value, topic, partition, offset, timestamp. Here, Kafka batch reader. This is my Spark session, then read, then dot. So I'm not doing anything. But from the data frame, schema automatically this is taking key, value, topic, and all. If you come here and see, the by default come to the data. Anyway, there is no data. So let's yesterday we had seen, right, that by default we are having this ID and okay, this is the leader. So inside the topic you are having key and value and timestamp, offsets and all that is coming by default whenever we are loading the data. So let me push some data here. Then we will see that. Here I have written one class for writing the data. Means I am not going to write the data manually. I will be writing the data dynamically. Okay. Automatically it will be creating the data and it will be keep on pushing. So what this is doing? I'm just simply creating a Spark session and this is the same config as I said. You can download this package and you can make this available. Then this is my Kafka topic name. Let me replace this test Kafka topic 2. Here I want to write. And then, okay, this is the Kafka topic. Let me copy this or let me delete it. Why 2 times? Not required. Then Kafka Bootstrap server. This is the Bootstrap server. Then this is the data. I just want to create some dynamic data. Okay. So data equal to key, then ID, then name. What is the name? This is the data means value. Then time is time. Then in the range, I in range of 1 to 11, just 10 records. Then data frame creation. Based upon this data, this will be creating the data frame. Then from this data frame, convert the entire row to JSON as a Kafka value. Then we know that we are having the key and we are having the value. So I'm just converting that to value column. Okay. And then I'm taking two JSON struct. I'm converting that to JSON format. We have two JSON. We have from JSON in the Spark. Then struct means that is the struct type. Okay. Then ID, name and timestamp. I am including this data there. Then write the data to the Kafka topic. This one. This is the Kafka topic name. Test Kafka topic 2. So I will just replace the name here. Test Kafka topic 2 means instead of pushing the data manually, just I have tried to make it dynamically. So how much means if you are looking for more data, then simply you can run and this will be pushing the data to the topic. Then select expression cast. I'm doing the casting and then write, then Kafka, then the same server, and this is the topic name, and then this is the topic name. That means okay, we are generating the data and I will be writing the data. So let me run this. Patch write current file. Then let's run this. And let's see how this is writing the data. Okay, this is done. Now we can check it to the Kafka topic. Let's go and here. Let's okay. Here you can see the data. Let me refresh. We can see we have the data, right? What is the total count? 1, 2, 3. Even you can see the count from here. Let's refresh it. Total count is 10 because we had given the range in the code to get the 10. If you go here, how much count you want, you can just simplify here. If you want, I can share the code. Where it is. I guess I am in the wrong. Okay, this one. Here I have given 1 to 11. So accordingly, this is taking the range. Now, if you come to the data, you can see partition, offset, key, value, timestamp. These are the default column for the data. Okay. So key, we should push the key because that key can be, and we can always make sure that key is unique so that we can make it as a unique one, and if we want to read some specific data, read and write, then we can do using this key column. So as of now, I have created just numbers as a key column, but you can make the combination. Then value what we had converted to JSON, right? If you look at the program, I had made it this ID, name and timestamp, and I am converting to JSON, and then that is getting pushed, that is getting converted as value column. And this is the okay, this is the key, and for this key we have ID, user, and this one. Let me verify that offset key, and let me expand this. So this is ID, name is user ID, and timestamp is this. So user 1, user 2. If you go to the code, here you can see user. Then user hyphen, what is the number? User 1, 2, 3, 4, whatever. Okay, this is the ID 1, 2, 3, 4. So accordingly, this will be keep on generating the data, and this will be keep on pushing, and then you can read and write. Here I have made it for if you want to write that continuous data, means suppose you are looking for more data. Then here I have written a program. Even that program also you can modify, but just I did it separately. So this is my topic name, then this is my server, this is my Spark session, and then here I am trying to generate some JSON data. So offset, let's say you want to have some range for not for offset, for another things you want to have some logics and all, then you can. So this time whatever you are looking for the uniqueness, okay, this is for the epoch time is time, then number of records I want, then starting ID I want to start from 0, and then the data. So for data offset here I want to append this one, uh, uh, means this is the key equal to offset plus index. So this is going to just make a combination. Then for this string UUID I am not taking. I was trying to take it for uniqueness, but I just removed it. Then starting ID start plus 1. Then this will be the incremental ID. Then you name I am just not creating some name. I'm simply taking user 1 2 3 4 5 to make it simply simple. Then this is the current Unix time is time. This is I'm just simply getting the time, and this is the value. Value is I into 10. Simple, no logic. If you want, you can have some logic like in the previous one I showed you. Then this is the schema, and then for this schema, I am just trying to keep the data inside value. Again, I am taking ID, name, time is stamp value, all for data. Here, while writing to Kafka, I am doing cast and then I am doing this one. To this Kafka topic, I am keep on writing the data. Okay. Then here I have given time dot sleep. That means pause for 10 seconds before generating more data. That means this is going to work in a loop. Let's run this. Okay, so if you see here, this is doing JSON data return to Kafka topic. So I will check here the count. Let's go to the count. Initially it was 10. Now you can see it is having 162. Then if you see this is keep on generating. Count is keep on, right? Until unless I will kill, that is going to run. Okay. So you can see here count is keep on increasing. That means if you want to do like that, the data should be keep on populating for your testing. You can use that. Then I will go to the data. Let me run this. If you see initially this was my first where I had pushed the key as 1 2 3 4. Here I have made the combination. So because of combination, this is coming like this. This will be kind of unique value. You can see 83, 84, 85, 86. I just try to make it in the incremental number, and here my value is. So this is my value. So like that I have the data, and then you can try to read from the Kafka topic and write to Kafka topic both. Like in this example, what I tried, I am trying to write to the Kafka topic. Means my source is something else. Something else means what? Here I do not have any source. I'm just keep on generating the data. That data is getting generated dynamically, and I'm pushing the data. But you can have some source and you can have some uh, targets, right? Like let's say this is video, and I will not go with this. Got it. And this one also. Kafka. This was the batch reader. And then let me run this one more time. Then I will go to the next. Let me cancel this class. This, let's make it terminate. Otherwise, this will be keep on pushing. Okay. Now let me run this. Kafka batch reader. So this is simply reading from one of the Kafka topic. And then I will take this for writing and batch readers. So this is reading the data. If you see here, this is simply key and value and timestamp. Here, this is in the byte array format before doing the cast. Now I can have this casting and then bootstrap Kafka server. So I need to copy from here localhost. Let me simply copy this both line and will take it here. So Kafka topic 2. This is just I will copy this name and then I will enter this. This is the topic name. This I need to delete. Okay, this is the Kafka topic. Okay, now let's I will not write into this topic. I will just create test topic and I will create here one more topic. Test topic. Let's make it 2. Add topic created successfully. Then let's run this. What is the issue? Driver stack trace. Okay. About in the job and error is something. Boolean exception applying default for error executor. Let me do the limit. Some limit I will do. Dot limit 10. So simply we can do read, we can do write, we can have multiple different sources, different targets, right? And accordingly we can have the scenario. I'm trying to simplify this because I am having simple this data frame, then trying to write this, not doing anything else. Okay, I'm doing wrong here. I have given 2 topic details, right? So this is why this is failing. So if I go to this one, this was Kafka stream writer. Then this is what we were doing. Kafka write streaming. It was option. This is wrong. This line is wrong. I hit it simply copy paste and that is creating the issue. And again, this is wrong. Test topic, right? So let me cancel and run it again. Still issue? Do you see any issue if something is wrong? Line number 27, I guess that this is fine because I have simply copied from this one. Stream batch right, Kafka batch right, and this was running very much fine, right? So I have simply tried to take this data, format Kafka, options, topic, nothing else. It is the same, but why? Here it is writing. Let me just say this. Then I can create one more class, but no issue. No need to create a one more class. Simply I will run this one more time just to verify. This let me check test topic. Just I will verify once if this syntax is proper. Format right. Okay, this is fine actually. Then why this is not working there? That is the same project. This topic, if we verify, now it is having the data. So if I go to this one again and batch reader, here I am having the data frame, and then even let me comment this one as well, not needed. And then test topic, let me run this one more time. Current test topic. Let me take this one and then localhost. What is the localhost? This is 9092. 9092. I guess something is there. Okay, no issue. So you can take it for reading and writing either from the Kafka to Kafka or maybe from different read from different sources, write to different targets. Okay, and do it with Kafka, do it without Kafka, read in batch, read in stream. Keep on writing the data, keep on reading the data, and if you want to have the data generation automatically, then you can. If you can let me know, I will share this code if you want to have this dynamic read and write, not read, dynamic write, so you will not be having any challenge to write the data manually. Okay, for your testing purpose, like here this is keep on creating the data and this will be writing the JSON data. So here I have mentioned how you want. You can have the limit. You can control this as per your requirement. How many uh, records you are looking for, or how it should be running with the times and all. So that can be. And then I wanted to tell you. Okay, so next we are having this one. Kafka streaming. So for Kafka streaming, I have to share some details. Let me cancel this because this will be again keep on writing the data. And if I am going to Kafka topic 2, yeah, this is fine. Now, if we are going with the streaming one, here you can see. So in streaming, we need some checkpoint location as well. Now you can ask me what is checkpoint. Any one of you have any idea what is checkpoint and why we need it? Not only for the Kafka, if you have idea about any other application as well.
Basically helps to debug the code.
No. So see, checkpointing means if you are running with the batch, then you know that, okay, let's take an example. Or let's say you are having some 10,000 records in your source. Okay. Then you are trying to process in batch of 1,000. Batch of 1,000. Then what you will do? First time you will be running it from 1 to 1,000, right? Second time you will be running from 1,001 to 2,000 like that, and it will be finally running from 9,001 to 10,000, right? That means you know that from where to where you have to run, and whenever you are planning for the batch, then what you will do, you will make your application intelligent to understand that what it was already means what was the data already processed and what is the next we have to. So maybe you can create a watermark table, means kind of temporary table, you can say watermark table, where you will be storing the previous processed records, some information, some metadata about that. Okay, then you will be saying, okay, you maybe just assume that we are creating watermark table, and there you are saying sequence, and then uh, the last started offsets, then uh, last ending offset, ending offset, and processed time, processed time, then application name, and then let's say topic name, topic name. Let's say these are some columns. You just created a temporary table, either with the SQL or with the Hive, or maybe you are just generating a file with this data. That can be, and let's say you are generating some CSV file and you are storing somewhere. So what this will do, whenever your application is running, it will be populating data for this. At the end of the run, it will be making okay, just some sequence number you can have either in the incremental or maybe some random unique number. Then last started offset. Started offset is 1,001. So let's say first time it is populating 1. Then last started offset was 1, and the last ending offset was 1,000. And then processed time. Let's say this is 6 Jan. 6 Jan and 2025, and then let's say some hour and minutes and seconds something. Then topic name, test topic, and then application name. Application name is test PySpark, PySpark with Kafka. So this is, again you can have offset detail also here. Like let's say you are having 4 offset, sorry, partition details as well. So let's say you are having 4 partition. So here you can have that data store as well. Like let me tell like this partition details. So here what you can do, it can say it can store the data like this. Uh, let's say this is storing data like this, and this is saying okay for partition 0, this processed from 0 to 10. For partition 1 means for partition 1 it processed so mm, let's take it like this. Okay, you can have this like this, means this is up to you how what is the format you are opting. So for partition 1 it is storing the data like something again from 0 to 12 like that. So for which of the partition what is the offset it has processed. So for 0 partition this has processed from 0 to 10. From partition 1 this has processed from 0 to 12. So next time it is going to make sure that okay from partition 0 I have to process after 10, and for partition 1 I have to process from 13. Next time when your application will be running, then this will be taking reference from this, that okay what was the last processed. It was started with the 1 and it was ended with the 1000. That means this time I have to start with 1001 just after this, and then I have to process up to 2000 according to the batch size. And then partition detail, this had 0 to 10 and this had processed this much, so I have to check for that. So this is kind of manual check. You can keep it, and then accordingly you can process the data in batch, and there will not be any chance of missing the data or you are doing something wrong. It will be completely fine. But if you are doing in streaming, then how it will take care, means in batch job you are good to take care. You can save the information somewhere and then you can refer the same information in the next run, and your processing will be happening accordingly. But here this is not going to work, right? Do you think that it will work in the same way? Because if it is running with the streaming, then streaming means what, keep on running. So last time maybe data came 100 record from the source. So this processed again. Next time maybe 85 records only came. Next time maybe 70 records only came. Next time maybe 543 records came. So different number of records are keep on coming from the source, and your streaming application is keep on running. Then it should get managed, right? Like how you are managing in the batch, how it is making sure. So this is maintaining it through checkpoint location. Checkpoint location is just a temporary location where Kafka will be taking the control. Kafka or Spark you can say, because you are working through the Spark application, and then it will be maintaining all the offset details there, that what is already processed, and means all the processing detail it will be capturing there. And the next time it will be processing with the same reference. Either it is keep on running in the streaming, or it is having micro batches. Micro batches in the sense, let's say it is running after with the interval of 2 seconds or 3 seconds because of some data volume and all. So always it will be referring all the details from the checkpointing location. So that checkpointing detail we have to provide during the streaming. Okay, so I can say here that about checkpointing, you if you are not better, you can give some temporary location and all, but you can define some location. And again, let's say you clean the checkpoint location. If you clean up, then it will not be having any reference, and then again it is going to do blindly from the beginning, means whatever is the availability for the data, because this has lost all the reference and all. So checkpoint, either we talk about, see, Spark is different thing, Kafka is different thing. Make sure that Spark is also having its own streaming. It is not dependent with the Kafka. Kafka is a different tool, Spark is a different tool. But it is good if we are working with the combination. Otherwise, without Kafka also you can work with the streaming. Like as I said, for the CSV, you are doing the stream, but your format was CSV, like that. You can have different. So if we talk about either about the Kafka or about the Spark, so checkpoint ensures fault tolerance by saving intermediate state data. Okay, this is the intermediate state data, that what happens in the previous run, and accordingly it is going to process the next run. So all the intermediate data, state data, is going to be uh, saved there, and it allows the Spark streaming and Kafka consumer to recover from the failure. If any failure happens also in the backend, this is going to recover from the checkpointing itself, because this is going to store all data there. Okay, and checkpointing, if we talk about checkpointing in the Spark, let's talk about both separately. So checkpointing in Spark. And let me check if it has created any checkpointing location, because I have made it D Kafka custom checkpoint. So let me check here. D and Kafka. This is Kafka logs we had created. Kafka topic 2.0. You can see the details, right? This is the Kafka log, not the checkpointing, but this is just whatever topic we have created. For topic 2, how many times this is running? So 0, 1, 2, 3. And this Kafka log we had given in this file. Zookeeper, here we had given Zookeeper data. And for server, we had given this one, where it went. For the server, we had this Kafka log. We had commented and we had given this one, right? So with the same name, this is taking. So you can go through all the logs and all. This will be giving you the details. This is leader epoch checkpointing. If you go, here will be some details. So let me open this with Notepad, and here you can say 0, 1, 0, 0. So anyways, don't worry about that to understand this. This is not complex, but as of now, yes, this can be if you are not having proper understanding. So that can be. So this is, you can say, a cleaner offset checkpoint, the start offset checkpoints. So this is going to maintain all the checkpoints, and here I had given an application for checkpoint location. Yes, the Kafka. Okay, this is the checkpoint. So if you see, this will be keep on generating metadata. Okay, with the temporary location, and then you can go and you can look out there. So a checkpointing is just to store the reference data, state data, intermediate data between the processing. So first let's talk about the streaming part, Spark, Spark part. If you are not working with the Kafka, then types of checkpointings are there. One is metadata checkpointing, Second is data checkpointing, and okay, let's talk about this one only. So metadata checkpointing. This saves metadata like offset, lineage information, and the streaming progress, like what is happening right now or what is done. And it needed when using stateful operation like windowing or update state by key. Windowing, I will be talking about that. That's the separate topic. Then data checkpointing. So data checkpointing means saves RDD data to the persistent store. Like you can have, let's say you are working with Hadoop, then your persistent store can be HDFS. You are working with Azure, it can be ADLS. You are working with AWS, it can be S3. If you are working with GCP, it can be different. For different systems, it will be different. It used when lineage grow too large, means long running aggregation. Okay, you are doing the aggregation, and that is going to go with the long run. Then how you can set up that? Let's say you are having a data frame, then data frame dot checkpoint, and then you are having one keyword here, pager equal to throw. Even you can say only checkpoint. Okay, then if you want to define the checkpoint, like how we did it here, you can see, let me just simply copy paste that. So I will uh, take this right stream, And let me copy this one. This is for that, but I will do for this. So this is, let's say, right stream, and then output mode. Me output mode, and let's say this is append, and then coming to the option is, I'm not going with the Kafka because I'm talking about a Spark, right? That's why I removed the Kafka. Then option checkpoint. Checkpoint, and then checkpoint location, and here let's assume that we are working with HDFS. Then HDFS, then we have, this is for the file location, and then this is your path to the checkpoint folder wherever you have created. Path to the checkpoint location, folder location. Then start. Dot start. So this is like that. So we can have our checkpoint location, and with that checkpoint location, this is going to work. Then let's say we are having one D stream also, direct stream with the Spark. So D stream based application can have, let's say you are having your Spark context, then dot checkpoint location, checkpoint, and then you can give the same path, your let's say checkpoint path, checkpoint location, like that. Then we can enable even compression for the checkpoint, because if the data is keep on writing to the checkpoint location, of course it will be writing for each of the batch, for each of the micro batch. This is going to generate some intermediate stateful data for all the states, for to capture all the information about the offsets, metadata, and all. This volume will be keep on increasing. So if you want, you can have the you can enable compression as well. Okay, how you can do that? This is the part of the optimization. So enable compression for checkpoints. How you can do that? You can say Spark dot streaming dot checkpoint dot compress equal to true. So like that you can have the compression. So it will be doing the compression. Now let's talk about Kafka, about the same checkpointing. Checkpointing in Kafka. So what is the type of checkpointing? Here I said metadata checkpointing and then data checkpointing. Here you have offset in Kafka. That is by default. You are not going to take care. As I said, Kafka is having the implementation that it takes care for the consumer offsets what has to save. So first I'm taking offset in Kafka itself, Kafka itself. So that is the default. Where what it will do, it Kafka stores consumer offsets in an internal topic like underscore consumer underscore offset. Let me just check it here just for the verification. Okay, I guess again it has got the issue. No issue. We will check that. Or I can go to this location and I can this is for consumer Kafka logs, and here is nothing. Then logs, and they see here you can see the state change and all, right? So let me go here, edit in notepad, and you can see all the details. Here it is saying like for zero partitions, state change logger, then non-existence partition. What about this will be getting? Then request to broker has set for zero partition, and then here if you see sending update metadata request to broker has set for 4 partitions, again for 0 partition, then correlation 1 from the controller 0 epoch 1. Then accordingly this is going to have all the details, and that is it's a reference. And you see part second partition, 0 partition, second partitions, everyone is having some different request. Then this is log cleaner, Kafka controller, authorizer. This is the log. So let me come to the zookeeper data. This is the zookeeper one. If you come to this notepad, and inside zookeeper properties, what you had set up? You had set up this data dir. We commented this temporary location, and we get this our own location wherever I want. So I wanted in the same my D drive Kafka location, zookeeper data. So here it has created zookeeper data, then version 2, and then log snapshot, whatever you have, you will be getting it. So now coming here, and if you see, all the details will be present here, but anyways this is compressed. So if you want to read it, you have to uncompress, then you can go ahead. Okay, then next let me back here. So this is for the offset. Kafka stores consumer offsets in an internal topic, and it will be for the consumer offset. Then offsets in an external store. Okay, so here offsets in an external store. So one thing is by default this is going to be with the consumer offset, but if you want to have with the external one, then it can work for you, and where it will be you can integrate with either let's say HDFS or ADLS in Azure, or you can have S3, you can have MySQL. Okay, you can have Zookeeper, means let's remove zookeeper not required, means you can have varieties. So this needed when using multiple consumers for the better recovery. Okay, and manual offsets checkpointing also you can do here. Let's say manual offsets checkpointing, where what you can do, save offsets in a durable storage location like HDFS or ADLS manually with the manual implementation, manual details. Then if you want to configure that with the Kafka, then how you can do, like here, this is what you can do in Spark. Then here, if you want to do the same in Kafka, then you have to do, or let's say I'm doing, this is some of the property, enable dot auto dot commit equal to true. Commit means what? This is going to commit the offset. Let's say you are having total 10,000 records with as per this example, and you read from 1 to 1000. That means this next time you are going to read from 1000 to 1. So what Kafka will do? Kafka will be committing this offset. Means this will commit means this simply save. It will commit. Okay, you have already read up to 1000. Then offset is saved. Next time it will be going with the next one. So this is going to have the auto commit true. And the next you can say auto commit auto dot commit dot interval dot ms millisecond equal to. If you want to run this auto commit with this duration in time interval, then you can provide that as well. Okay, and if you want with some manual, let's say you want to have some uh, manual offset management, then how you can do. I will just give a sample example that how you can do. Then even whenever you are defining in your code, you can take care of it. So let's say I'm saying def. I'm giving a definition. Def save offset. Save offsets. And then what can be my offset input parameter. First thing is data. Data means my data will be inside the df, then batch id, because I am going to process the data in the batch. Let's take first batch only. Okay, then that can be microbatch also with the streaming one. And here I'm saying offset equal to my data frame, then dot select whatever I want to select. So this is select. Let's say I have some topic, then then partition, then offset. My syntaxes can be wrong, so don't focus more on that. Just focus on the logic, what I want to do. Then let's say I am doing some group by offsets, and then dot group by. I want to do group by with topic and then partition. Partition. Okay. And then doing some aggregation. Let's do that. So then aggregation, what I want, I will take the offset. So offset, and then let's take this max offset. Okay, and again let me take it as JSON. This one. No, I did wrong. I should have do it here in aggregation. This is, and then max, and then let's come to the next. Then let's say here I am doing the aggregation, so I will be just doing the column rename. Just I am including that use case also to revise with column renamed. I want to make a meaningful column name. Then simply in the previous step we are doing max offset. So I will take this. That is going to be with the default one. Then from this max offset, I want to have the column name offset. And then I think it's done. Then I can say my offsets dot write dot mode, and let's say override, because always if I am saving the offsets and all, I do not want to store all the versions. Whatever is the latest, just save that. So next, because next time we need the latest detail only, right? That what was the last one. So what was the last one, you can take it. So let's make it override instead of append. Override, and then top, keep in the JSON format. Anyways, you can choose the format, whatever is the better one. And this is your checkpointing location. Checkpoint location. So here it will be keep on saving. Now, like this, you are going to save the offset manually. You are going to save this offset, and next time whenever you are reading, you can say, let me make that code as well. How you can do? Again, I will say don't focus on my syntax. That can be wrong. I'm just trying to make it a sample. So query equal to spark dot. Let's say I'm going with the stream. So read stream, 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 and then dot format. Dot format. Let's say format is Kafka. I am working with Kafka, and then I am working with dot option, and here let's take Kafka Bootstrap. So Kafka dot bootstrap server and then subscribe. So let me copy the code from here. So this is, let me take it and this one. So we can provide the bootstrap and topic detail which we want to read, then dot load. And once we are loading, then next what we want, let's say, okay, so let's say I read that. After read, I want to write again. Then let's take write stream. Even you should not do in the single syntax. Let's take in different. I am just combining. So write stream. Then for each batch, because we are having we are working in the stream, right? So we are going for each one. So let's take for each batch. Then save offset. This is the function name save offsets. So I will take save offsets and then dot start. So like that you can have the verification for the manual management. Then if you want to do the restoring offsets from the checkpoint storage, that also you can do with your own logic. And means the thing is simply if we are talking about the checkpoint, that means that's a location which you have to configure, and with that location it will be having all the intermediate state data about all the transformation or what is the what is going on. It will be having all the details and it will be taking that just as a reference. Okay, without this it will not be having the prior run details and it may do wrong. So you should have that will be keep on updating all the time along with your job running. Now we can say again, as I said, you are having both the option for the streaming when you have Kafka also, which you can work either alone with Kafka or a combination with the Spark, or you can do with the Spark without any dependency with the Kafka. Not required that for all the streaming you are looking for format Kafka only. No, this format can be changed. If format is changed, then this bootstrap server will change because bootstrap means server means what? This is the server detail for this format. If this format is changed, then this server detail will be changing. Then this topic detail will be changing, but remaining all the concepts will be same. So if you're working with Kafka or if you're working with the Spark, you can consider something like if we are working with the Spark, then stateful transformation like we have Windows group by state and all. This is Spark checkpointing touch. Kafka offset checkpointing doesn't do for window stateful transformations and all. Anyway, the stateful transformation we will discuss tomorrow, so don't worry about that. Then we have one stateless streaming. Like let me note down that word. One is stateful, one is stateless. Okay, so stateful is done in Spark checkpoint, but not in the Kafka, and the stateless streaming is done in Kafka, but not in Spark. Then if you are having long running Spark application, then Spark checkpointing is good. And if you are having consumer only Spark application, then Kafka one is good. Kafka checkpointing because consumer and producer concepts are better in the Kafka. And you know consumer and producer, right? Whenever you are trying to write the data, that is a producer. Like I was writing some data to the Kafka topic. That means I am producing the data. So that is my producer class. And in another class, I am trying to read the data. That means I am just consuming the data. So if whenever you are trying to write the data, then you are managing a producer class. Whenever you are trying to read the data, then you are managing the consumer class. Then Kafka topic retention period and all. Uh, So Kafka topic retention is unreliable. If we talk about reliable or unreliable, then with this Spark checkpointing, that's better, and with Kafka, not, because all are having some different functionalities. So both method, either you are going with the Kafka or you are going with the Spark, it can be used together for robust fault tolerance in streaming applications. And if we are combining both, if we are working with both other things, then we are doing good. Okay. Then we have for the streaming one, we can have multiple streaming concept. Like we can have, let's say, okay, so let me give you one use case. Let's say you are keep on ingesting the data from the source. There can be one use case that data is too much. Sometimes data is coming. Okay, let's say that you have allocated 5 resources, means 5 executors to run 5 machines. Okay, with 5 machines, you are assuming that if I am getting some 10,000 records, then it will be working fine. It will not be having any failure because of memory and all. But what happening in your system, 10,000 data is coming, but let's say this is 8 a.m. 8 a.m. it is getting some 100 record only, and 9 a.m. it is getting some 1,000 records, some 8,000, 9,000 something. Let's say if we talk about some login details and all, we have multiple web application where if you look at the data volume in the morning time, evening time, then early morning who is active? Very less users, right? Late evening, very less users. And if you see the daytime, then visitors are more. If you look out for any web pages or any application, e-commerce, financial banking or anything, in daytime their count will be more, and early morning, late evening count will be less, because that's unusual time. So like that, if whenever count is less, then it is fine. But whenever immediately count is going to be flow, then that can have an issue. So you can manage that. You can say that, okay, if a count is coming with this much, then make sure that I am reading in this batch. Let's say you are getting some 10,000 records. Then you can say that read. Okay, and sometimes we are getting out of 10,000, sometimes we are getting 5 records only. Sometimes we are getting kind of 200. Sometimes we are getting 1,500. So count are different. If it is coming with 1,500, then it is good. But if when it is coming with 500, let's say 5, 3, sometimes one visitor, sometimes again one visitor, this is bad, right? Because for single and very less user, for very less data, your application is keep on processing, and what it will do finally, if it is running for a single user, what will be the impact? Any idea about this? It will be writing a small file, right? Because for a single user, this is going to generate one output. Again, for the 5 user, this is going to generate one output. So that will be very small. And if it is having some good number, then file size also will be good. So in this situation, this is going to return lots of small files and all. Again, you are having the problem. Problem is that if your business demand that don't care about the number of users and all, whatever it is, either a small number or big number, let's keep on processing, then this is not in your hand. You will be doing as it is. But if your business says that, okay, you can take care of it, we are not in hurry, even we are good if we can process minimum 100 at a time, then you can instruct in your application that, okay, check for the count. If count is less than 100, don't process, just wait to message be up to 100. Once size is reaching up to 100, then let's take all together and process that. That one you can set up, or you can say let's go with the size. Okay, is whatever data you have to process, does it meet for minimum 10 MB? If so, I will process. Let's let 10 MB is more, let's take 1 MB. So if it is 1 MB, then process. If not, then let's wait for the data. Okay, like that you can set up either with the number of message or with the size of message. So you can say like enable automatic back pressure to adjust processing rate dynamically. Either you want to enable or disable that. Then max rate per partition, how many partition you are having, then what should be the max rate means number. That means limit the max message per partition for the Kafka input. Then you can have a consumer poll timeout. Okay, that Kafka timeout for the consumer polling, if there is no data for some time duration, then it should be out. Then receiver write a head log where it will be enabling to prevent the data loss. Then for micro batch, if you are working with the micro batch, then we can say Spark streaming batch duration. What should be batch duration? Let's say I'm saying 5 seconds. So that we can do either true or false, and then we can say stateful operation, either true and false again. Then shuffle partition, if you want to take care for the shuffle, that define the number of shuffle partition for distributed processing. Shuffle partition should be 1, 2, 3, 4 or 100 or 200, whatever you want, because for narrow transformation shuffling partition count will be different. For wide transformation shuffle count will be different. Even you can do one exercise and you can validate in the backend how this is creating the partition, number of partition in the sense all the stages and tasks and all. It creates internally stage and tasks, right? So you can verify that. Then interval for the background state mechanism. So volume based control. Volume based control in the sense unpersisting or deletes from memory after processing each batch. And getting the count wise allocation, as I was saying that okay, you are looking for to fix some size, that if this size is matching, then process else wait for that. The number of threads, compressioning, multiple things are there which you can take care while you're working with the streaming one. So but anyways, I will capture all the details all together and I will share that. Okay, if you have any question you can just let me know. I guess that it is a little bit confusing. It is or not? No,
Somewhat.
it is right. Yeah, so this is new concept. So with new concept, this happens. That's why I said, because this is completely new. So if I am talking about stateful, stateless, checkpointing, if you have nothing in mind from the means if you have not heard it any time, then of course this is going to be, but going forward this way you will be familiar with it, because this we are going to repeat this multiple times, right? So this will be fine first time this happens. So just you can mm, concentrate over the checkpoint just to can understand what this is, because that can be the point of your interview as well, interview discussion, that if you are working with the streaming, then what is the things you are taking care. So they are checkpointing is the major thing you can talk about. And then you can talk about the limit, as I said. By default this will be keep on running with the incoming data, either less records or more records, doesn't matter. But if you want to have a control that I want to process minimum these many records, you can. I want to process with minimum this much volume, you can. Or immediately your application is meant to be built for 10,000 capacity, and immediately data get processed, you are started getting data like 15,000 and all. In that case also you can have the control. You can say that okay, if this count is exceeding, then let's process in micro batches. That means let's 2 second window, and in 2 second process something 1,000 or 5,000. Then again 2 second and 5,000, and again 2 second and 5,000. That means in total 6 seconds they will be good to process 15,000 data, and the application will also not fail because of out of memory and all, because it is having capacity of 10,000 only. So if it will process at a single time, that may stuck, block, fail, that there can be some error or some issues. But if you manage this with the uh, windowing, then it will be always good because you are having capacity of 10,000 and you are processing with 5,000 only. Then this will be good to process. So you can manage all the things with the configuration, Spark configuration, how you want to process. Okay. And this will be coming with the direct stream. That means if you are keeping the 2 seconds, that means this is not real streaming. Okay, this is micro batch. Real streaming here it is waiting for 2 seconds, right? So once it is waiting for 2 seconds, how it can be real streaming? Real streaming means it should not wait for anything. It should keep on processing. So this is this thing. Like either a 5 record, 1 record, 2 record, 200, 1500, whatever it is coming. Let's keep on processing, but only make sure that your application is capable to take care of that. It is not failing just because messages are more or something. So that is up to you if you're working with the real time actual streaming. But if you want to manage, you can manage, but only condition will be this will be turning to micro batches. This is because you are going to have some window setups. That window will be open for this time, and this up until this 5,000 processed, remaining 10,000 will be in the queue. That will be in the waiting state until unless this is done. That will not be coming in the picture. That this will be processing start the next batch only once this is done. So according to that, you can again assume, okay, for 5,000, how much time I really need? Either I need 2 seconds or I need 5 seconds. If you are taking 2 seconds and this is taking lots of time, it is getting stuck or it is creating a issue for the next batch because after 2 seconds again it will try to read. Then let's make it 5 seconds. So based upon your data volume, based upon your data, based upon your transformation, how much complexity it is having, you can always take care of that and you can handle. So this is what you have to take care during your covering with the processing and streaming and okay, I believe that it was okay. So I will share the code and exercise for Kafka batch and streaming both. You go through the exercises, you do that, and then try to do that with checkpointing, without checkpointing and all. If possible, you can try to keep some logic for offset management as well manually. Kafka is already taking care, but you can do that. Means just do some R&D here and there. Then your learning will be more. And then for the Spark streaming, I have some options to. Means for Spark streaming, we have multiple options, but I will be capturing few topics, and we will discuss that tomorrow about windowing and all, including this stateful, stateless. Then we will be good with Spark streaming as well. Hope it is good. Okay, Chandan has also joined. Chandan, you joined very late.
Not very, only 20 minutes.
Okay,
7:20 I joined.
then fine. Okay, then I hope that you got the point.
Yeah, I will go through. I will
Okay, yeah,
let you.
that's the required. Otherwise, it will be kind of confusing only because this is completely
Yes.
new topic, right? So you
Yeah,
have
yeah.
to go through that one time, two time, then you will be familiar. And
Yes.
you need this code, whatever I showed you for pushing the data dynamically.
No.
Okay, fine then. Fine, then I will share the exercise just to go through that. And I have created one folder for the Kafka, separate folder, and I will be uploading in that itself, just to go through that.
Okay.
Okay, fine. And then have a good day. Bye.